Okay, we're going to talk about using the reality desire algorithm to sort sequences with orientations. So, a sequence with an orientation is a sequence of numbers where each number has a set orientation to it. Doesn't need to be numbers, but we're using numbers for this example. So here we have our unordered sequence and then its target ordered sequence. So how do we get from the unordered to the ordered? We're going to use this reality desire algorithm.
Here we have our unordered sequence, 5, 2, 1, 3, 4, 6, with its different orientations, and we want to translate that into the list that's going to give us the basis, the foundation for our reality desire diagram. So we get this L plus 5, minus 2, plus 2. So the plus and minuses come from the orientation of the arrow, because the plus is going to be always at the whichever way the arrow is pointing. That's where the plus is. The tail of the arrow is the minus. So 5 points to the left, so plus 5 followed by minus 5. 2 points to the right, so minus 2 followed by plus 2. Now once we have that list all made, with our L and R, our front and back, we're going to add in the reality edges. Now reality edges are the edges that exist between two elements that are adjacent in our unordered list. So L is adjacent to plus 5, minus 5 is adjacent to minus 2, and you can see this in our list above. So add in all those edges. And now we add in our desire edges, and these are the edges that exist between two elements that we want to be next to each other. So plus 5 wants to be next to minus 6, L wants to be next to minus 1, plus 1 wants to be next to minus 2, all the way through. So that's that, and then we're going to move on to our next step.
Place those elements on a circle. So now we have our reality edges are still present in the circle, and now we're going to place our desire edges. So as you can see, desire edges just go between things we want. L goes to minus 1, minus 3 goes to plus 2, plus 1 is going to go to minus 2, minus 5 is going to go to plus 4, plus 6 is going to go to R, and minus 6 is going to go to plus 5. And then plus 3 is going to go to minus 4. So now we're just going to highlight the two different cycles we have here. We have one big cycle and then one little small cycle that just has one reality and one desire edge. This is sort of our goal for all the numbers in this entire thing. We want them all to end up in these pairs of just these little cycles where you only have one edge of each. So right now in our graph we have two components, and currently each component is just made out of one cycle. So a desire edge is a straight line between 2 points on the circle, and a component is made up of the intersecting cycles. Right now in our last image the two cycles did not intersect, so they were each their own components. Components can be good or bad, and good components have at least one diverging cycle. If no cycles diverge, the component is a bad component. And a cycle diverges when it has more than one reality edge. And those orientations go opposite ways, but we'll show you that in a moment. So back to our cycle, we can see that the small little red cycle down here is actually too small, and it's done. This is our final state that we want for stuff. So we don't need to worry about this guy anymore. We're just going to focus on the black cycle. So we're going to put on an orientation. So we just pick a direction to go from two nodes. It can be arbitrary, and then you just follow through what that orientation does to the rest of the cycle. So as you can see, we're just adding in that orientation all the way around. Now we're going to apply another orientation around the outside of the circle that's either going to be clockwise or counterclockwise. So here we're just going clockwise. Again, it's arbitrary, but it just needs to be the same direction all the way around the outside of the circle. Now we want to look for divergence, and that's places where the arrows are going different directions. So the black and purple arrows, where do they disagree? Well, there, there, and there. So we have three diverging edges. So that means we have a good cycle here, which means that it's a good component because it consists of at least one good cycle. Now we need to perform our sorting reversal. So the first way we hopefully get this sorting reversal done is we need to pick one of our diverging edges and then pick one of the edges which went the opposite direction as it. So we're going to pick this one up here, and we're going to perform a reversal by swapping the two values and all the other values that sort of go inside of it. So the next slide, we can see that we've reversed all the values between those two edges. And now we're going to recompute our desire edges and redo our orientations as well to see if we've created a good component or a bad component. If we've created a good component, then we've done a sorting reversal. And if we've done a bad component, we have to do something else. So again, we're applying the purple around the outside to see if we have divergence. And yes, we have some instances of divergence. So we made a good cycle, so that was a sorting reversal. Now we need to pick one of those divergent edges, one of those three, and one of the other edges. So we're going to pick these two and perform a reversal. Again, we put on our desire edges. That +1 -2 has again reduced to this small little cycle where it only has one reality and one desire edge, so it's done. And now we apply our orientation and we check for divergence. Yes, we have divergence because not all the black arrows are going the same direction around the circle. However, we have 3 that diverge and 1 that agrees with our orientation of purple. So when we pick our edges for our next reversal, the one that went the other way has to be one of the 2 edges we select, and we can select one of the other ones. So now we're going to perform that reversal, recalculate our desire edges, and then apply our orientation. Now we're going to check for divergence. Uh-oh, we do not diverge, we converge. We've created a bad component. So what this means is that this is not a sorting reversal, so we need to go back to our previous setup and select different edges to perform a reversal on. So this time we're going to use that same edge up there and this edge down here, reverse, and put back in our desire edges, apply our orientation, check for divergence, and yes, we diverge. So this is a sorting reversal. We've made another good cycle and thus a good component. So we move forward. Now we need to pick the edge that diverged and another edge that right there, perform a reversal. Desire edges go back on, apply the orientation, check for divergence. Yes, we have divergence. Select those 2 edges that diverge, perform the reversal, put back in our desire edges, and now everything has been placed into these small little groups of the cycles with 1 reality edge and 1 desire edge. And if you look around the outside of the circle, everything is in order. And that took us 5 reversals. So we're all done there. And all it took was 5 reversals. Now you can calculate the minimum number of reversals that you're going to need to do if there are no bad components. You know it's going to be n plus 1 minus c of alpha, where n is the number of elements in list and c of alpha is the number of cycles. In our example that we just did here, we had 6 elements in the list and 2 cycles after we put in our initial desire edges, which gives us a minimum number of 5. So we were able to do this in the minimum number of reversals. If you have any bad components right off the start, then your sorting reversals to sort that is going to be greater than or equal to the same equation. So that's it for part 1, and now in part 2 we're going to talk about what to do with bad components and different types of bad components.